For the third part of this lecture set, we'll be talking about guidelines, again, for ethical practices in research, specifically for psychologists. So to start with, we have oftentimes referred to as the Belmont plus 2, but this is just a set of 5 guidelines or outlines that the APA, which stands for the American Psychological Association, has put forward. This is just a technical, you could say, an amendment to the original Belmont report, not that that doesn't still apply. It's just lots of different associations and places have made these types of ethical documents, and they don't always all line up. So we're left with a lot of different ethical documents that we pick and choose and merge and use for everyday conduct. So beyond beneficence, justice, and respect for persons, we have another 2. The first is fidelity and responsibility, and the second is integrity. So fidelity and responsibility centers around the idea of avoiding conflicts of interest. So this would be not doing research on your intimate partners, not sort of, I guess, having intimate relationships with someone who is coming to you to seek therapy, not unduly using your power as a professor to force students into doing research. All of these types of things would fall under this class of fidelity and responsibility, and the examples I gave are things that should be avoided. When it comes to integrity, this refers to how well professionals are ultimately sticking with their field, you could say. When it comes specifically to professors and researchers, they're obligated, one, to stay up to date on their current research, but much more importantly in regard to them, not to mislead people in regard to the material that they are experts in. So it would be unethical for a professor to come into a class and teach students incorrect things. Right? You could not go into a class and tell people that sour things were sweet and sweet things were sour, to use a little bit of a joke example, because technically that would be unethical. And as a professional in a sort of academic field, it is your ethical responsibility to provide information to your students in the most correct form that you know how. When it comes to therapists, and not only just general therapists, but psychologists and psychiatrists would fall under this category. Here, again, right, not to mislead people, but also to stay up to date on the current field. It is, technically speaking, unethical for a therapist to be practicing therapy that is outdated or has been used decades ago and has since been, by research, shown to be ineffective, or if there are other methodologies that are shown to be more effective. This, unfortunately, is something that is oftentimes stated in ethical documents, and if you go out into the world itself, there is a huge variance between what types of practices various psychologists and psychiatrists are practicing and the degree of efficacy and research behind them. It is unfortunate that there is still quite a big divide between clinical psychology and, let's say, the more research intensives, cognitive and social types of psychology. And unfortunately, that divide can sometimes lead to situations where therapists are not actually practicing the most current or effective means at providing interventions. Even though there is a huge debate about this in the field, and a lot of that ultimately comes down to different camps and how they approach dealing with research. Now, if you thought that that was not enough standards, then don't worry, we have even more standards to talk about. And there is an APA document that put forward 10 standards, and now these are separate than the Belmont plus 2, even though put forward by the same people. And if you want to read all 10 and all of the subheadings under each of those 10, I have put that document, the most recent version, up on iLearn, and you can look at that. Now, we will only really focus here on the set that are under Standard 8, and even in those, we will only focus on a few of the points in Standard 8 because those are most pertinent for psychological research. The rest cover more general research and in other fields as well. So the first of Section 8 that falls under this is the mandate of using institutional review boards, or IRBs, as you'll hear them talked about a lot, and when people are frustrated, they oftentimes refer to them as the irrational review boards, but that's just researcher frustration. Now, Any location that conducts research on human subjects and accepts federal money, by that I just mean money from the government, they must have an IRB. They're legally mandated to have an IRB. Now, this is true in the United States of America, but not necessarily the same in other countries. Now, many countries have similar processes and other countries are much more lax, and that just depends on the countries themselves. Now, if an institution does not take any money from a government, they're technically not mandated to have an IRB, even though there are many such institutions that do anyway. Things you can think about here are private colleges that do research. While they might not take or accept any federal grant money and are able to provide all of their own money through their own endowments, many of them will also still have IRBs or use IRBs at other institutions to sort of make sure that their research is above board, even though not all of them do and they're not required to. Now, things get a little bit more messy when it comes to private industry and them doing research. Now, there is an interesting debate here, I think, between whether they should be required to use IRBs or not, because, well, in many ways, private industry won't actually ever publish their data. They will do a tremendous amount of research on human subjects, but they won't ever use that data for public purposes because it's proprietary and they're going to use it for their own profit and market development. Now, should it be required that they follow ethical principles as well? One could say at a general level, yes, that would be wonderful, but IRBs are not mandated for private industry, for example, and so they're not necessarily required to have any kind of ethical oversight, which probably is one of the reasons why we have so many of those sticky situations that pop up on the news every so often about big tech these days mostly, but ultimately about any type of industry. There are some fascinating studies that were conducted by fossil fuel companies back in the 1980s on effects of carbon emissions on climate change, but most of those never actually got published because they were conducted in-house, even though they showed very similar findings to what many climate scientists are talking about today. Right? That might sound appalling that they knew 40 years ago that human use of fossil fuels is changing the current climate, but technically they're not mandated to share that because they didn't actually have to publish that data, because you don't have to publish anything really. And because they're not publishing it or wanting to publish it, they're not required to have IRBs either. Now, an IRB must have the following. It has to have at least one scientist. It's also got to have at least one other academic who's in a field outside the research being discussed. So, for example, I could, in a research-oriented IRB for a psychological study, I would need a psychologist, and I could have also, say, a philosopher or a physicist or a biologist or a linguist or just some other academic who's not in the field of psychology. And then you'd also have to have at least one non-affiliated community member. So by non-affiliated, we mean that they're not affiliated with the university or the institution that has the IRB, and that they're just from the general community. Now, it could be somebody's grandmother, it could be someone who heads the local Rotary Club, it could be something like that. And it doesn't only have to have one of each, it can have multiple of each of these. In fact, oftentimes the more diverse an IRB is, the better they are at approaching these types of situations. Now, another comment about IRBs is that while they should do their best to limit unethical research, there's a fine line between limiting unethical research and limiting research that is controversial or skirts the line, you could say. And that is ultimately why it is so important to have IRBs, because a good IRB will prevent all unethical research, but it will also not be overly preventative at doing novel research either. Moving on down, this is yet another subsection of that Section 8 standard in the APA, is the use of informed consent. Now, ultimately, an IRB will determine whether or not you need to use an informed consent. And, well, that being said, you won't ever get in trouble for having one if you don't need one, but the opposite is going to be pretty bad and oftentimes will result in either you or you and your institution being sued by whoever the people who are making a fuss about it. Now, an informed consent is basically a document that you provide to the participant before starting any of the research. And in this document, you have a little bit of background around what it is this study is about, the specific things that they will be doing, along with what benefits they could potentially have, what benefits will go to the general public, what risks they are the potential to incur. And so this can be anything from you're about to see graphic images and that can be traumatizing, all the way to we're going to attach electrodes to your skin. And while in 99% of the time that electrode paste is non-irritating to human skin, there are some people who get irritated. And so that would need to be put under risks as well. Once all of those things are made aware to the participant, and it all needs to be written in language that makes sense and is easy to be understood by the participant, right? You cannot give someone who speaks Punjabi, for example, an informed consent in English if they do not speak English, or even if they have trouble with English. That would be unethical. Further, to have someone who has no understanding of any psychological jargon and you have a jargony heavy informed consent, that is again unethical. At the end of these documents, normally you will have a space for a signature and a date for both the participant and the researcher. And you will oftentimes have 2 copies. Both copies will get signed by both people and 1 copy goes to each individual. Now, research that's completely anonymous, meaning that there's no way to identify who took part in that research, oftentimes don't need informed consent documents. Though many times when researchers are conducting such research, they will have a document on the front that looks a lot like an informed consent document. It is often referred to as an implied consent document because you can't actually guarantee that the person understands that document itself. But also in a lot of those situations, they are anonymous and so it is not required. But like I said in the beginning, good practice. Now, deception. So this is something that people have lots and wildly different opinions on about whether it should be used at all, whether it is beneficial, whether it degrades perceptions of the field, whether it's the most fun thing to do in research. People have very widely different ideas. But now, when we're talking about deception, there are technically 2 classes of study that fall under a deceptive study, and when people are talking about deception, they almost overwhelmingly focus on one and not the other. So the one that people tend to focus on is where the direct purpose of the study is withheld from the participant. So you're actually either providing a different cover story where you're telling them something other than what is actually the case, or you're simply omitting parts of the study so that they don't know what it is they're about to be in. And this is oftentimes what people are talking about when they're talking about a deceptive study, or when you're telling somebody about deception, this is what they tend to think of most. Now, in and of itself, that is not necessarily bad, and it's sometimes required to do certain types of research. For example, if you wanted to examine how people will behave in startling situations, you can't tell them that they're about to be startled because then they're unlikely to be startled. And in those cases, at best, your study is now contaminated because you have people who are expecting. And expectancy biases are a huge thing actually that gets studied in cognitive psychology. And of course, this can now be much broader. There are many, many contexts where we want to see what people will do without them having prior knowledge. Now, the second class of studies, which actually embodies far more studies in the field than the former, but is oftentimes not thought about, is any kind of study in which you have multiple conditions in which a participant only goes through one single condition. If you do not tell the participant beforehand that there are 1, multiple conditions, and 2, that there are differences across those conditions, technically that is a form of deception as well. Just we tend to have less of a sort of ethical tizzy about those situations than the first. But technically a direct lie or a lie by omission are both lies, even though I don't think deception is actually lies, but that is neither here nor there. Now, as I said before, It's not inherently unethical, but there is a lively debate around this issue, and there are some very extreme opinions on either side. Whereas, like, deception is the only way to have a good psychological study, and deception should just never be used, and it can never be ethically justified. Like many things in life, the truth is somewhere gray and in the middle, and is oftentimes very context dependent. Now, don't worry, you don't need to know the ins and outs of every single type of deception, and oftentimes the IRB will determine whether a type of deception is justified. And they will do this before the study is conducted. So the way that works, just as a quick primer there, is that before you're able to do research, legally at least, you submit a document to the IRB that not only explains what it is you're trying to do and why, but also a step-by-step play of everything a participant will go through. So it will be everything from participant will enter the laboratory, participant will sit down at a table where they will complete an informed consent document. They will then be tested on whether or not they understood that document. Then they'll be taken to a different room, sat down in front of a computer, blah, 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 all the way through all the things that they will do. This is how then the IRB is able to determine beforehand whether a study is ethical or not. And in the same way, whether deception in it is justified or not. Now, whenever deception is used in a study, it mandates the use of a debriefing. Now, debriefings are where the researcher then explains the complete nature of the study to a participant, along with whatever the hypotheses were in the research or set of studies that they're taking part in, and how the data that you will get from the participant will help you answer or test those hypotheses. Again, these debriefings must be written in a form that is able to be understood by a participant. So it's not illegal to have some jargon, but you don't want it to be too jargon heavy, and every time you use jargon, you want to explain what that is. So a good sort of balance here would be that while a couple of words might be misunderstood, you want your grandma to get the overall gist of what just happened. Oftentimes, you will also ask once more if participants consent to the use of their data in a debriefing. Because just because you got consent at the beginning of a study does not guarantee that there is still consent at the end of a study. And like with all things in life, people are able to revoke their consent at any point in time. Now, a more particular form of debriefing that comes up a fair amount, even though you'll almost always see this in cognitive psychology, is called funnel debriefings. And what this does is it has the regular debriefing as I talked about previously, but before that you ask the participant a series of questions. And those questions oftentimes pertain to their experience during the study, what strategies they may have used to complete the study itself, and what they thought was the purpose of the study. In so doing, you can figure out whether they had ideas about the true purpose of the study itself, or if they saw through the deception, so to speak, before actually looking at the study. And this knowledge can be highly beneficial because, as I was saying earlier with, let's say, expecting a startle versus not, people who are expecting a startle will behave very differently than people who are not expecting a startle. And so if your set of individuals, half of them were able to intuit what the true hypotheses were and the other half were not, you have added an additional variable of difference across your participants, and this can ultimately lead to the presence of an additional confound. Now moving on to research misconduct. So two of the big branches here are data fabrication and data falsification. So data fabrication is probably the most blatant, and this is just where you invent a set of data that fits a hypothesis. You don't even bother to do a study, you just make up some data. Right? So this could be at a joking level if you were to take a chemistry class and you have to write up the reports of the chemistry experiments that you do. You can actually just look up those studies because they're classic studies and then just work backwards from what you expected, and you can create an entire sort of research lab report that there is no actual experiment behind. I don't recommend doing that, but that's kind of how that would work. The much more common form that we see in the field, more often than you would probably like to think, is data falsification. And this is now when you modify your data in some way, or you influence your subjects in some way. So modifying your data could be adding or deleting data points, and influencing subjects could be putting all of a certain type of people in one group and all of another type of people in another group so that you guarantee a difference that you are wanting to see. Now, it need not be just so blatant as adding or deleting data points. There's a lot of strange wiggle room that the field is really trying to deal with right now. You hear this a lot when people are talking about the standard of p less than 0.05. You hear a lot of studies where people will receive or find a significance test that gives them a probability value of, let's say, 0.0052 or something, where it's 0.02% above what the threshold will be. And people will oftentimes say something like, it is trending in that direction. Now, there's no way to know that it is trending in that direction. Just because that's where the probability value is, it could equally likely be slightly lower, thus making it significant, or slightly higher, moving it away from that threshold. And there is actually no way for a researcher to know that after conducting such a test. So even the idea of something is trending this way or that is actually a form of fabrication or falsification in this case, even though there it is much more gray than simply deleting or adding data points. Another problem that comes up here a lot is the running of additional subjects, even though one had only thought to have a certain number. What will happen here is that, let's say, again, someone has a significance test that they run on their set of data that is very close to the significance threshold. And one unfortunately common practice that will happen is people will run an additional set of subjects. And oftentimes that running of additional subjects will move the significance test then down in terms of its probability value, leading to a significant finding. That, however, has nothing to do with the actual effects itself and can oftentimes be manipulated just by the sheer numbers of subjects involved in a particular study. And that is ultimately a limitation of many of the parametric statistics that we use today. And not necessarily because the statistics themselves are bad, but because they were designed and built in a time when to have 30 or 40 participants in your study was doing big things. And now that we can have potentially hundreds of thousands of people in our studies, it makes the way in which we operate and interpret our statistical tests a little bit more fuzzy. And unless you have good background on how that works, it is easy to be led astray. Now, this can have really serious world consequences, or real world serious consequences, excuse me. So first of all, a lot of people, when they hear about this stuff, will think about the shame and discredit that can come to a researcher or an institution, right? They're a liar and a cheat, and how could they do this, and what evil people? But there are more, in my opinion, serious consequences that can result from this. So nicely, your book actually makes mention of this, but this is something just to be aware of. So in the late 90s were a set of studies conducted by Wakefield and 11 other authors. And this study supposedly showed a link between the MMR vaccine, which is the measles, mumps, and rubella vaccine that most people in this country just oftentimes have. You chances are have this weird yellow little booklet that has your marks of vaccines in it, and that will have an MMR vaccine in it. Now, this study and a couple of the other ones that these people published showed a link between the MMR vaccine and the development of autism. Basically, they said not only is it just related, but taking the MMR vaccine makes it more likely that you're going to get autism. Now, this is widely credited whenever you have people talking about skepticism towards vaccines in today's world, right? This basically is thought of as one of the sort of foundational pieces that led to the bloom of the anti-vaxxer movements that currently exist today. I mean, in fact, it is still widely cited when people are wanting to make a point that vaccines are not safe, right? And this is very different than, say, the people of Tuskegee in Alabama, even today, right now, being skeptical of vaccines for the coronavirus because of the history of what happened in Tuskegee, right? That's not really the same thing. Now, a little bit of background for this. They ran a regression model with only 12 individuals. You can ask anybody who's worth their salt and has done any kind of statistics, and they will tell you that that is meaningless. You cannot use 12 individuals to have a good predictive model about a relationship. And further, a predictive model like that does not establish causation, even though they said and claimed that the MMR vaccine caused autism. Later on, it came out that not only had these people fabricated the data, right? Well, excuse me, not fabricated, falsified the data by cherry picking which ones were in. It later came out that these people were actually paid by lawyers who were hired by a series of parents who wanted to sue vaccine companies. So this whole thing became a huge mess. You can read up more on this and you will find literally 100 studies that have all refuted the link between the MMR vaccine and the development of autism. Some of those studies have upwards of 50,000 individuals in them, just to make sure. Now, even though much of that work has been conducted, popular knowledge does not look at all of that other research that was conducted and becomes hyper-focused on this one set that proves positive what it is that their fears are centered around, that vaccines could be dangerous. Now, I'm not saying that people cannot have negative side effects from vaccines. Of course, that is always a case that is possible. But by and large, vaccines are actually quite safe and have saved millions and millions of lives over the last 30, 40 years, let's say. I mean, the fact that we could remove smallpox from the population and have almost completely eradicated polio, both of which are utterly debilitating diseases, is a testament to the effectiveness of vaccines. Now, I'm not saying that we should just ignore anti-vaxxers and just call them stupid and disregard all of their fears, but it is important to know where a lot of that ideology stems from and what they're basing it on. So when they say I have evidence, oftentimes they're talking about something like the Wakefield studies, and those are just, they don't hold up. And so falsifying data can have mega huge consequences, because I mean, look at the world today and the massive increase of anti-vaxxers and how that can cause dramatic impacts. I mean, there have been mumps and measles outbreaks here and in the UK that never were a thing before this happened. Right? We'd been using those vaccines for ages beforehand. Right? It's in some ways we have regressed. And so one should be very, very careful with this. And just to leave this, even though there's tremendous pressure in the field to get significant studies, only publish significant studies, it is just as important to know what doesn't work as it is to know what works. And unfortunately, we rarely publish what doesn't work because it's not as citation worthy and buzzworthy. And so our field becomes more and more skewed, only talking about stuff that works and ignoring all of the stuff that didn't. Even though when it comes to research, both are equally important. One last piece of research misconduct, even though maybe less heinous than the previous two, is plagiarism. This is just defined as the appropriation of another person's ideas, processes, results, or words without appropriate credit. Basically, especially in any kind of research document, if an idea comes from somebody else, credit them. Right? That's just how it works. It's not that you can't use it, it's just credit them. Right? One of the most wonderful things about the scientific field as a whole, in my opinion, is you read a cool study, you want to use that type of study with only a little manipulation, you call up the researcher, well, send them an email to be honest in these days, and you're like, yo, could you send me the material for your studies? And oftentimes they will send you that material. And then as long as you just credit them, you have a whole study basically ready to go. Finally, to conclude a little bit on animal research, here's another thing that people have both wildly differing opinions on and oftentimes very strong opinions on. But in general, when it comes to animal research, there is an institutional animal care and use committee, which apparently is pronounced IACUC, which is just kind of weird, but whatever. And it works much like an IRB to determine whether the research being conducted on animals is ethical and humane. And just to make a point of how varied and strong people's opinions can be, most of the primate labs, for example, in the United States that do studies with primates are actually secret and their locations not disclosed because they will be attacked many a time by advocates. Not that all advocates are attacking research laboratories, but it does happen. Overarching sort of idea of how to manage and do good animal research falls under this idea of the 3 R's, which is replacement, refinement, and reduction. So moving backwards, reduction is just use as few animals as possible. If you could do your study with 28 animals per condition, use 28, don't use 50. When it comes to refinement, this is just if you're able to manipulate the way in which you're conducting your study without compromising the hypotheses or the data, modify it in such a way that you can minimize the animal suffering and distress. Right? Both in terms of the actual scientific process itself and how you're going to keep those animals. Right? So if you can do a study that will be over in 2 weeks, there's no need to have that study go on for 3 months where you're keeping an animal in a cage the whole time. Finally is replacement, and this is when possible don't use animals. This is actually becoming more and more, maybe not common, but something that is more and more possible now through the use of artificial intelligence, machine learning, and simulations because of computational power and advances in the algorithms that we've been using recently, even though ultimately algorithms makes them sound really, really fancy, and what we're doing is optimization problems that are just a slightly more advanced form of the statistics that you were actually already probably trained on. The underlying math is surprisingly similar. So in a case where you could do a simulation, run a simulation instead of actually using animals.